Okay, in this one, I'm going to go over the last free response question, number 3. And they've set up a two-sample t-test where it looks like they're comparing the average time it takes for two different types of coffee cups to essentially cool. And so they're trying to prove, this company is trying to prove that the new design, the new cup, is going to have a higher average time or longer time to go from 150 degrees to 100 degrees. So in theory, that it should insulate the coffee longer. That's the whole point here. So in terms of describing a type 2 error, it's been probably a month or so many weeks since we've discussed type 2 error, but you can't just forget about it, even though we've moved on to doing hypothesis tests for means. So remember type 2 error, so let's just do generic first. All right, so type 2 error is failing to reject the null hypothesis when you should have rejected it. Okay, so that is type 2 error. So again, that doesn't answer the question though, because we need the context of the study. So if we fail to reject the null, that means we still think that the average time that it takes for these cups to go from 150 degrees to 100 degrees in terms of the liquid inside is the same, right? When in fact it's not. When in fact it actually is better. So it takes longer to cool down in the new cup. So I'm going to write that, but essentially make sure you are focused on the context. So in this study, committing, I feel like that's spelled wrong. Don't know which one is right. I'm going to go with it. A type 2 error, good thing it's not an English exam, would mean thinking the average time for the two cups is the same when in fact the new cup is better. And by better, I mean taking longer for the liquid to cool. All right, so it keeps your coffee warmer longer. Okay, so that is part A. Part B, the company is concerned about the probability of committing a type 2 error. Which test procedure, one that uses an alpha of 0.1 or one that uses a significance level at alpha of 0.01, would result in a smaller probability of type 2 error? Well, whenever I try to introduce type 1 and type 2 errors, I tried to explain that they are always kind of dealing against each other or working against each other. So if you want to minimize type 2 error, well, then your type 1 error is going to go up. If you want to minimize type 1 error, well, then your type 2 is going to go up. So I have an inverse relationship. So if we're trying to have a smaller type 2 error, right, what ends up happening is we have to actually increase the type 1 error. And when I first talked about this, hopefully you remember that your alpha level is your type 1 error or your likelihood of committing a type 1 error. All right, so if we want to increase type 1 error, we need to increase our alpha level. So between these two, 0.10 would be our choice because it is greater than 0.01. All right, so that is just these two questions. I put this in here because this question is asking about a hypothesis test for two sample means, and I wanted to make sure that you hopefully remember that your type 1 and type 2 errors are still around, right? They still exist, even though we moved to means. Whenever you're doing hypothesis tests, you got to remember type 1 and type 2 errors could exist. All right, so that's it for number 3.